before we start multiplying complex numbers together, there's one fact about I that we should discuss, and that is, what does the quantity I squared equal? And if we think about it logically, I squared is I times I. By definition, I is the square root of negative 1, so this becomes the square root of negative 1 times the square root of negative 1. When we multiply a quantity by itself, it's the same thing as squaring the quantity. And by definition, we know inverse operations, squared and square root cancel out to give us negative 1. So if we shorten that, I squared is really the same thing as negative 1. When I square the complex number I get the purely real number negative 1. That's an amazingly important fact that's going to come up in almost every single one of our problems. So if we look at a problem of multiplication of complex numbers, something very simple, like 6i times 3i, we want to go ahead and multiply the real portions together. 6 times 3 is going to give me 18. When I multiply I times I get I squared. And we know from above that whenever I have I squared, it's really just the same thing as negative 1. So essentially I have 18 times negative 1, which is negative 18, a real number. I can extend this same sort of reasoning to a more complicated problem that has 3 parts to it, like 2i times negative 6i times negative 5i. I'm going to take this in chunks. First thing I'm going to do is multiply 2i times negative 6i, which would give me negative 12 when I multiply the real parts together, and I squared. And that's all multiplied by negative 5i. But I know that when I take I squared, it's really just negative 1. So negative 12 times negative 1 is really just a 12 times negative 5i. I multiply that out, and I get negative 60i, which is my final answer. So again, the important thing to realize is that I squared equals negative 1. When I start multiplying, the next progression in multiplication is to look at distribution. So if I have a problem like 3i times 8 plus 5i, all I have to do is distribute the 3i to each of these pieces. So 3i times 8 is still going to give me 24, multiply the real parts, and then I. The second half, 3i times 5i, is going to give me a 15 from 3 times 5, and I squared, which we know that I squared is negative 1. So if I clean this up, I have my 24i, and 15 times negative 1 is negative 15. And remember, style matters, so I have to write this as the real portion first, negative 15 plus 24i, the imaginary portion second. After simple distribution, we look at problems that involve FOIL. So if I take a complex number, like 2 plus I, and multiply it by another complex number, 3 minus 2i, it's easy to relate this in your head to the polynomial process of FOIL, and it's going to behave exactly the same. 2 times 3 is going to give me 6. 2 times negative 2i is minus 4i. I times 3 is plus 3i. And I times negative 2i is going to be minus 2i squared. And remember, I squared is negative 1, which makes this whole quantity right here into a positive 2. So when I go to combine like terms, I pick out the real portions of 6 and positive 2, which gives me 8. And I pick out the imaginary parts of negative 4i and positive 3i, which gives me minus 1i, or just minus I. That's my final answer. If you ever find yourself with more than 2 parts to a complex answer, you did something wrong and did not reduce the powers on I correctly. The last thing that can happen to make this slightly more difficult is I could have a problem where I have two complex numbers, something like 2 plus root negative 16 times 2 minus 4i. Here I have to do a little bit of cleaning up of the problem before I go any further. And I just have to realize that root negative 16 is 4i. The negative underneath becomes I. The 16 gives you the 4 when I take the square root. So I would rewrite the problem as 2 plus 4i times 2 minus 4i. And if I'm thinking about what I'm doing as I'm going to realize right now that I actually have conjugates, which is going to be very important when we start dividing. But for now, we know that conjugates have middle terms that cancel out. So let's see what that does whenever it's a process involving complex numbers. When I multiply 2 and 2, I get 4. 2 and negative 4i would give you minus 8i. 4i and 2 is positive 8i. And 4i and negative 4i gives you negative 16, and then I squared. But we know that I squared is negative 1, which makes this whole quantity here a positive 16. So when I go to combine like terms, I put real with real. 4 and 16 gives me 20. And then imaginary with imaginary, which are my middle two terms, which cancels out. So when I look at conjugates in a complex sense, I'm going to go from two complex numbers to a purely real number. So that's the process we use to multiply complex numbers. It's just really important to remember that I squared equals negative 1.